So I apologize. I was rearranging this and deciding like what order I wanted things to be in, and I didn't redo the numbering. I am very sorry. So the numbers are all out of order. But I was trying to like streamline it and get it to all fit on one sheet of paper. So I'm sorry. The numbers are out of order. You'll be okay. All right. So yeah, thank you for, being young adults about it. It's not that big of a deal. All right. So first one, what can you do to factor the numerator? Yeah, take out 3x. That would leave you with x plus 1. Anything divided by itself is 1. So these first few, and I'm sure you can tell from looking here, I'm not going to ask you for the whole list of everything. There's only 2 that I'm going to ask you for the whole list of everything. Here, I'm just kind of picking and choosing some things. All right, and then how is the denominator going to split?
X plus 2,
x plus 2, x minus 2. Perfect. Does anything cancel out there? No. So you would not have a whole. I didn't ask you that, but that's what that would be. So I just asked you for like a few things, not the whole list, just kind of picking and choosing. So who are your 2 troublemakers that you're going to kick out of the domain? Yeah, good. And so it's going to be negative infinity to negative 2. You have to go smallest to biggest. And then negative 2 to 2, and then 2 to infinity. So you're booting those 2 out of the domain.
Yeah, I didn't know that when we took the quiz. I almost wrote like the bigger number first.
Yeah, it's a number line. You want to think of it like a number line, so it has to be smaller to bigger.
Yeah, I just want to get a bottom equal 0.
Correct, because you're not allowed to divide by 0. All right, vertical asymptote. Nothing canceled out, so there are no holes, and you have 2 troublemakers. So that means they both became vertical asymptotes. So you have 2 of them. Now, I would not like for you to write plus and minus 2. That's not appropriate here because it's 2 separate vertical lines. So you do need to write them separately. So, and again, I'm not making you graph this, but you would have a vertical asymptote at negative 2, and you would have a vertical asymptote at positive 2. So you'd have 2 of them. I was abbreviating here to get it all fit on one sheet. This is horizontal asymptote or slant asymptote. You have to compare your powers. So look where I'm pointing. What's your degree for the numerator? 2, and then this is 2, so they're equal. So that means it's going to be horizontal and y equals 3. Good. It's your coefficients. It would be 3, bless you, 3 over 1, which is just 3. Okay, and so your end behaviors are both going to go to 3. Like it's going to match. So those are both also 3.
Which one is when the numerator is bigger?
That's the slant.
Oh, and if the denominator is bigger than it's
0. Good, perfect. And you're sitting close enough that showed up on the recording, so I love it. Let's say it again.
I have a question.
Yeah, good.
If this, since if you have like factors that cancel out, the one that you cancel out on the bottom that isn't like, okay, like in this one, like if the top was x plus 2 and you canceled out both the x plus 2's, would that not be a troublemaker anymore?
It would be a troublemaker and it would become the whole. The one that cancels will become the whole. I have ones on here that do that. Just hold on a minute. All right, what can you do to factor the numerator on number 2? Yeah, take out a 4. That'll leave you with x minus 2. And then the denominator is going to split. Draw your 2 sets of parentheses. It'll be x and x.
Okay.
Yep, good. 2 and 4, and they're both minus. Nice. Some factoring problems are easier than others. It's a mixed bag. There's a lot of different types of factoring. Those ones aren't too terrible. All right, these cancel again. That means there's a hole, but I didn't ask you about it, so don't worry about it. Vertical asymptote would be x equals what? Who's your other troublemaker? 4. Y-intercept, you're going to plug in 0. I'm doing these what I think is easiest to hardest. I always try and start with the easiest thing. So if you plug in 0 for x, you're going to get -1. Good. You can plug into the factored one or the original one. It's not going to make a difference. And if you even want to just rewrite this, like up to you at that point. Now the x-intercept, you would set the whole thing equal to 0. What's a good? Why is it going to be none? 4 does not equal 0. 4 equals 0 does not make any sense. Did you have a question? Oh, yeah, same. It's Monday. Hey, this is our last full week of school before Thanksgiving though. So last full week we have to get through. All right, number 3, draw your 2 sets of parentheses. Hang in there with me, guys. So it'll be X and X. 14 is going to split 7 times 2. Yep, good. So who is your troublemaker that is getting kicked out of the domain? -2. You only have one troublemaker, and it's -2. Boot him out.
Wait,
Because it's what makes it 0. -2 plus 2 will give you 0. It's whatever makes the denominator 0, because you're not allowed to divide by 0. It's not a thing. All right, so -2 is going to become the whole. How do you get the other part?
Plug it in.
Yeah, plug it in. So I'm going to cancel these out. If you plug in -2, what do you get out of the -9? Good job. Yeah. Are you okay?
Where's the bottom of the denominator?
If there's nothing there, if it suits you and you want to put it over 1, you can, but nothing. You don't need to write the 1. All right, x-intercept is going to be something 0. You would set this equal to 0, and good, that would give you 7. 7 minus 7 is 0. And then the y-intercept, if you plug in 0, you get -7. I didn't make you graph this one, but if I did, it would be the line with a hole in it. Do you remember those? Just the line with the hole in it, because the whole thing kind of canceled out. All right, and then last one of these. Correct. Yeah. Yeah, and it would be a slant asymptote, but technically like the line ends up being the asymptote. Do you remember we did one in the notes and the remainder came out to 0 because it worked out perfect? But, I have 2 on the back of this that you will actually graph the whole thing, which I think I'm going to go to next. We'll do all the graphs and then we'll do a break and then we'll do all the equations. All right, so x minus 3 is your numerator. Draw your 2 sets of parentheses for the denominator. You guys are quick. Yeah, 3 and 5, and they're both negative. I know. Some people say it faster than I can even write it, which becomes difficult for me because it's my job to keep us all together, and then you make my job difficult, all right? So these cancel, and that means that your whole is going to be at where? Yes. Now, hold on a second. If you want to rewrite this, it's 1 over x minus 5. The x minus 5 is in the denominator. So you have to take 3 and plug it back in, and now it'll be -2 in the denominator. So it's -1/2. You take 3 and plug it back into what's left. If you're like, no, I don't want to rewrite it, that's fine. Personal preference, that's you. So 3 became the whole. I didn't make you write the domain for this one, but who's your other troublemaker that's going to be your vertical asymptote? It's 5. X equals 5 is the other one. So 3 and 5 were your 2.
So basically you're always going to be opposite.
Yes, because it's 0. You've made me say that like 5 times. It's not. It isn't. 3 minus 3 is 0. That's not confusing. Right? Now we're going to compare our powers. What's the power on the numerator? I got to talk everybody through it though. What's the power on the numerator? 1. Good. And then this one is 2. So yes, smaller. That means it's a horizontal asymptote and it will automatically equal 0, which means both of your end behaviors are also 0. Will they ever touch 0? No, it is behavior. So for those, I'm just kind of picking and choosing certain things. I'm not going to make you do 6 whole graphs. That would be a lot. So those ones, I just kind of did like a few things. Let's flip over and we'll do the ones where you have to do the whole graph. This is like your quiz 2.0. You guys did well in the quiz, just do it again.
Okay, I thought of how to phrase my question.
Okay, go ahead.
So, like a problem like this one, when you have factors they cancel. So obviously the one that cancels becomes the whole. But do both of these, like if you had like the
domain, both of them are troublemakers. That's why I try to get you to write the domain before you cancel them out, because then people forget to include that one.
Okay, so they would both.
They're both troublemakers. All right, number 5. What do you notice you can divide out of everything in the numerator? 3. I'm just going to write right above that and divide 3 out of everything. So it would look like that. And then that makes all the numbers smaller. So the 3 is still there. And you're like, Ms. Cole, sometimes we get rid of it. That's when you're solving an equation and it equals 0. And the reason I say to get rid of it is because 0 divided by anything is 0. That's not what we're doing here. We don't have this set equal to 0. We're just factoring it apart. So that 3 has got to stay in there. We can't just get rid of him. All right, and then how are you going to split up 4? You can do 1 and 4 or 2 and 2. Yep, 1 and 4, good. Oh, I didn't even put my x's in. That's bad. Yep, positive 4 minus 1. And then draw your 2 sets of parentheses for the denominator. I'm going to remember to put the x's this time. You're splitting up 3. So yeah, 1 and 3, good, and they're both negative. Perfect. This one really is like your quiz 2.0. This one's going to turn out like exactly like your quiz did.
Looks just like
Yep, it looks just like it. Just do it again. I'm checking that you still know it because some people turn in the quiz and immediately forget everything. I'm just making sure you still know it. All right, so who are your 2 troublemakers for your domain that you're, yep, 1 and 3. I won't take off if you forget to put a union. For heaven's sake, if your answer's correct, fine. I always think it's funny when there's 2 x-intercepts and people put a union between them. That's like, I don't mark that wrong either, but I'm always like, not what that means. So which one is going to be the whole, the 1 or the 3? Yeah, the 1 is the whole. The 3 is the vertical asymptote. So sometimes I just like, I'll try to just go ahead and put one of them here and one of them here. I'm like, okay, the 1 is the whole, the 3 is the vertical asymptote. And then you can dot that in on your graph. I like to just do stuff on the graph as soon as I find it. Like, hey, I found something. I'm just going to put it on there immediately. So then to get the other part of the whole, you're going to take 1 and plug it back into what's left here. If you want to rewrite all of that, you can. I'm not going to do that in this case. 1 plus 4. That's 5 times 3. So your numerator's 15. We all still together? And then 1 minus 3, negative 2. So it's 15 over negative 2. That'd be negative 7.5. Okay, if you want to think of it like 14 divided by 2 is 7. So 15 divided by 2 would be 7.5. So 1 and then negative 7.5. So like there-ish. Between negative 6 and negative 7. Oh no, I'm sorry. It should be between negative 7 and negative 8, huh? 6, 7. Oh, I put it in the right spot. I just said it wrong. Negative 7.5. So between negative 7 and negative 8.
oh,
Sorry, I put it in the right spot. I just verbally said it wrong. I apologize.
I was plugging in the clue.
Oh, you can plug in the 1. So then I would do the other asymptote. Compare your powers. What do you notice? They're equal, so you're going to use coefficients. So it'll be y equals 3. If you want to dot that in the whole way across, you can. Just understand if something weird happens, the graph might go through it in the middle. So I usually just do it only on the edges. It won't in this case. I'm not going to give you a super weird one like that. But when we get to AP calculus and then something weird does happen, I'm like, remember, it's just the edges. All right, so all this is great, but it's all invisible. It would be great if we had some actual points. So let's go back and get our intercepts. Y-intercept, you're going to plug in 0. You can plug it into the original one or the factored one. It's not going to make a difference. Go ahead and plug in 0. What do you get? It'd be negative 4. Good job. And then it goes right there on your graph.
Is it not negative 4/3?
So 0 plus 4 would be 4 times 3
I keep forgetting.
is 12. Divided by negative 3 is negative 4. Or you can plug it into the original one, and if you just cover up all the x's, you get negative 12 divided by 3. Either way, it'll come out the same. All right, x-intercept is going to be something 0. You're going to set the whole thing equal to 0, but look. 0 times anything is 0, so this is all gone. And then 0 divided by 3 is still 0. Like all of that gets absorbed. So what's the only number that we're gonna get? Is -4. Good. And that's weird. They came out to the same thing. That's a coincidence, okay? It's not always gonna be the same. Yeah, these are not always the same number. That's coincidental. All right, and then you can go ahead and connect everything. And basically the only way you can lose a point on the graph is if you run through the asymptote. If everything you draw matches what's here, I give you credit for the graph. So that's really the only way you can lose credit on the graph, or unless it's like super egregious, like I'm like, oh, this is a little bit too wrong. Otherwise, you're going to get credit for the graph part. And then you can use your graph to go ahead and answer everything else. Which do you want to do next? Range. Sweeping downwards to upwards. Basically, just watch me sweep this, all right? Scanning, 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 scanning. Oh, there's a hole. So we're going to leave out what number? Negative, yeah, I knew what you meant. -15 halves. Like that thing. Or -7.5, however you wanted to write it. Correct. Range is Y. All right, so we're there. Scanning, scanning, scanning. What's the next number we're going to skip over? Yeah, the asymptote, which is 3. And that's 3. All right. Oh, good.
Would you say this is one of our like not easier units, but like easier to like comprehend units?
Usually it's one of the harder ones. It's just going well this year. Every year I get a new batch of students and they're all always different. So it's usually the polynomial unit is what everyone calls the easier one. Because once you get used to synthetic division, you can just start like running through them. Also, when the remainder is always 0, you kind of know the answer before you do the question.
Wait, so what's synthetic division the hardest?
Probably the exponential logarithmic one, because just no one likes logarithms. It'll be unit 7. We're not there yet, though. Let's focus on what's in front of us. I get everybody through it every year. And then the second half of the year is trigonometry, which is like sine, cosine, tangent. Okay. Hey, guys, let's focus on what's in front of us right now. Reading left to right. What is this graph doing? Yes, decreasing. So increasing is none. What do you copy over for decreasing? The domain. If your domain is wrong, but you copy it over for decreasing, then you get credit for decreasing. So I grade it in a very holistic way. Like if your stuff matches, then I give you credit for it because you're being consistent. And then what are both of your ends going to level off at? 3. Good. It's going to match the horizontal asymptote. And same thing on the other side of the paper. If your horizontal asymptote is wrong, but you write your end behaviors to equal the same thing, then you get credit for the end behaviors, because it matches. We'll do that other graph and then we'll do our like halfway brain break. So number 6, you're going to draw your 2 sets of parentheses. And how is that going to split? 3 and 2, good. 3 is negative, 2 is positive. You only have one troublemaker. Who is your troublemaker? 2, boot 2 out, causing problems. Or 2. No, I don't feel bad for 2. 2 caused a 0 denominator. Get rid of them. We're like the bouncers. Gotta kick them out. Is 2 going to be the whole or the vertical asymptote? Those are the 2.
Vertical.
Good. Nothing canceled, so there is no whole. X equals 2 is the vertical asymptote. None is like the best answer. Good, you guys are already saying it. Why is it a slant asymptote?
Numerator degree.
Numerator is bigger. You're gonna remember that. It's the only way you can do a synthetic division is if the power in the numerator is higher. All right, what goes in the little box? 2, good. Your countdown is in order, 1, -1, -6. Go ahead and do your synthetic division. We don't use the remainder, so whatever that comes out to, just get. Some people don't even finish the problem, which I'm fine with. You don't need it. We don't use it. It is considered insignificant. When you're talking about infinite numbers, like as big as you can possibly imagine, it just becomes
Oh, I
insignificant.
see what you mean. So like, that's the only way to do is to asymptote.
Yeah, you
That makes
can't
sense.
do a synthetic division if the powers are the other way around. It simply won't work. So if you're paying attention, you're not gonna. Now these are both ones. You have to write this in y equals mx plus b. So it's y equals 1x plus 1. You don't need this one. I only wrote it because I'm doing the problem in front of a whole group of people and I'm trying to show you where these two ones went. So it's y equals 1x plus 1. Yes, slant synthetic. That works out nice verbally for us. So when you graph this, you start at +1, and then your slope is 1, up 1 over 1. So just instead of a line, just make it an asymptote. Just make it dotted.
You would cover up the one side.
For the end behaviors? No, you cover up the middle.
Yeah, like this.
Yes, and then you look at the left, but just hold on, we're not there yet. All right, this is all great, but it's all invisible. So let's go back and get our intercepts. If you plug in 0, I would probably use the original version for this one. You can just cover up all the x's, because if they're 0, then they're gone. You get -6 over -2, which is 3. Good, so 0, 3, which would be right here. And then your x-intercepts, you set the whole thing equal to 0. 0 times anything is going to just be 0. Interestingly, what do you notice in this one? You have 2 x-intercepts. What are they?
Oh,
3
and 2.
and -2. Good. So you're going to get 3, 0 and -2, 0. No, I just did that so no one will put a union. You don't have to put anything in between. You can put a comma or just nothing. I wrote the word and so no one will put a union. Again, I won't mark it wrong if you put a union, but it always makes me chuckle. Like, that's not what that means.
You know, they put it on both on the two sides. Like,
What a union means is our answer's not done yet. What it means is this thing in its entirety constitutes one answer. This is not all one answer. It's actually 2 separate answers. So a union is not appropriate there. But I don't mark it wrong. So we're getting into like splitting hairs here. All right, so 3, 0 would be right here. -2, 0. Wait, where am I at? 1, 2 would be right here. And then all you have to do is connect the dots and don't run into the asymptotes. So do you see how this point is right here? It's going to coast along this asymptote and then go through the other point and then coast along this asymptote. So it's going to look something like that on this side. And then we have to go through this point and just, again, don't run into those invisible fences. So it's going to look something like this. It's like a very wide hourglass, like a very like large hourglass is kind of what it looks like. Oh yeah, yeah. I would bring that up too sometimes. It's like those shock collars for your dog. It's an invisible fence. You just can't cross it. All right, so here we'll do the end behaviors next since you guys were talking about it. If you go ahead and set them up, then I'll show you. You just use your hand to cover up the middle of the graph, and then you look at the arrows on the edge. So like, watch what I just did here. Do you see how I just covered up the middle? Where is the left arrow pointing? Down, and then the right arrow is up. And the ones I give you are always going to do that. In real life, could it be the other way around? Yeah, if you flipped the thing, it could be the other way, but I like to reward you for listening to me. If you listen to me, the left side's going to go down and the right side's going to go up there. I'm rewarding you for paying attention. See how that works? You listen to me, then you reap the rewards of that. All right, range is actually kind of interesting for this, sweeping downwards to upwards. What do you think? Yeah, you don't lose anything. There's no hole. And it goes downwards and upwards forever. So you got everything. And then reading left to, yeah, everyone is invited to the range party. All right. And then reading left to right, what is it doing? Increasing, oh, whoops, what am I doing? Increasing, you're going to copy over the domain. Decreasing is going to say none. All right, so those were all the graphs. Now we're going to go back and do the equations and the inequalities. So it's really like switching gears. Instead of like a picture and all these characteristics, this is very much like hard algebra here. So I don't know where your preference lies. If you like the algebra better, this will more be your thing. All right, so looking at number 7, you're going to factor this. I would just write it really small right below. I did try to get this all onto one piece of paper for you so I could be, saving trees. Just write small. When I worked it out, I did manage to get it to all fit, so you can too. Now, surprisingly, that's going to factor into x plus 3, x minus 4. And my suggestion is scribble out what's there so that you look at the factored version. Now, that is your common denominator. And I'm going to tell you the same thing, give you the same advice that I did when I taught it. Write it 3 times. I know that it's annoying, but it's not difficult. And if you make a mistake, I am more able to give you partial credit the more that's written there. If you see what cancels and what stays, you'll be more likely to have the right answer. And there, in the time that it took me to give you that pep talk, you all finished writing it. So what cancels for the first term there? X plus 3. Now you can see what's left is x times x minus 4. So what's that going to give you? Yep, good, perfect. Distribute it through there. X squared minus 4x. You're distributing this x into the parentheses. What cancels for the second term? Perfect. Now you're not distributing a 2, you are distributing a negative 2. So that will give you negative 2x minus 6. Perfect. Equals. And then for the last one, it all cancels. So just negative 14. The whole point is that all the fractions should go away and it should look a lot simpler. Now, do you see a squared? That means evacuate. This squared means you're going to need to factor. So we're going to add the 14 over. And then also I'm going to put my like terms together. So this would be x squared and then what? Minus 6x. And good. Okay. I thought I was going to have to talk you through that, but you guys got it? Equal. Thank you. Don't lose your equal sign. If you lose that, then you lose what makes it an equation. All right, draw your 2 parentheses. It'll be x minus 2, x minus 4. You get 2 and 4. Keep one, keep the other, keep them both. Yeah, which one do you get rid of?
4.
4. Why 4? It's a troublemaker. Who was your other troublemaker? Negative 3 was the other one.
Oh, it's opposite.
Girl, you gotta get that.
I'm sorry, my brain doesn't like that. Wait.
Yeah. I just put the like terms together there, just condensed it.
So the troublemakers were negative 3.
Negative 3 and 4. All right, look at this one. Do you see how it's just a single fraction equal to a single fraction?
Yes.
So you're going to cross multiply, but give some hugs.
I love that.
When you cross this way, it'll be negative 6x equals, now this way, it'll be x squared plus, good, 3x plus 4x is 7x plus 12. Do you see a squared? Yes, that means evacuate. So you're going to add the 6x to the other side.
Squared.
Get 13x, because 6 plus 7 is 13, plus 12. Hey, here, again, at a point where you're saying it fast, so I need to keep everybody together. So, yeah, good. It'll be plus 1 and plus 12. So you get negative 1 and negative 12. Keep them both, get rid of them both, get rid of one or the other. What do you think?
Keep them both.
Keep them both. Your troublemaker, you only had 1, was negative 4, and we didn't get that, so keep them both.
I think there was the 6 and 1.
Oh. Okay.
Oh, yeah, good question. Yeah, this doesn't have a variable with it, so there's not a troublemaker there. I'm gonna save these two for last because they are not equals, they are inequalities, so I'm gonna flip over.
That was fun.
It says the
The
sum.
number line.
What does the word, yeah, we'll come back to it. I'll just save it for last. What, adding. So it's something plus something equals something else. You guys were my group that didn't like the lines that much. But it does sometimes help people, so I'm still gonna write it that way. All right, 3 times a number, how would you do that? 3x twice the reciprocal. That is 2 times the reciprocal, or just 2 over x is fine as well. But the reciprocal, I like to write it that way because it's like the reciprocal of 4 is 1/4. You know, the reciprocal of 5 is 1/5. The reciprocal of x is 1x. All right, equals 5. Now, the only thing that's in a denominator is x. So you're going to multiply all of these by x.
As long as putting the two on top, so you can see the, all the other ones. in the bottom.
Yeah, exactly. But it comes down to personal preference. I like writing it this way. If you like writing it that way, that's cool. Like, it means the exact same thing. You guys get to, like, when you get to upper level math, you do get to places where it's preference like that. All right, so this will be 3x squared. Do you see why it's squared? Everybody there with me? Okay. Plus, and then 2 times 1 is just 2 equals 5x. Evacuate. Now you would subtract over the 5x and put it in between. Good. Now that's a tougher factoring problem.
I'm sorry.
You are a genius.
I just.
So you're going to draw your 2 parentheses. It's going to be 3x and 1x. Now, this is one that it kind of works both ways, but the symbols only work one way. You're going to need the 1 here and the, no, wait, I did it backwards. Dang. You're going to need the 1 here and the 2 here. And then what symbols to get a negative 5x in the middle? Good. And the reason they're both negative is a negative times a negative is a positive. The numbers work the other way, but you'll get a negative instead of a positive. All right, and then 2 answers. I'm gonna have to write it over here. I ran out of space. This one would be 2/3 and 1. Keep them both, get rid of them both, get rid of one or the other. Keep them both. Who was your only troublemaker? 0. And you guys were excellent about that. Usually when it's 0, it throws everybody off. But yeah, the only thing that will make this denominator 0 is 0 itself. All right. Last topic here is our number lines. Yeah, okay, so to be clear, your test, I made it more pages. I usually try to conserve trees on the study guide. I'll try to condense it together. All right, numerator is going to split x plus 1, x minus 2. To save yourself some space, just go ahead and write it like this. X plus 1, x minus 2. You're going to have a number line for both of those. How is the denominator going to split?
X minus 3, x minus 4.
Good. X minus 3 and x minus 1. And there's nothing weird going on. That was going to be the next thing I said. Nothing's squared, nothing's backwards. You don't see an extra negative anywhere. So how did I tell you to fill in your number lines if nothing weird happened?
Plus, or minus.
Negative, good, and then turn positive. Now you do have to get your numbers in order though. Which one is going to be the smallest 0 that we get? 1. For the x plus 1, it's going to be -1. All right, let's hold it together. -1. And then +1. And then 2. And then 3. I almost kind of ran out of space at the end here. Let me lengthen these lines a little bit. It looks like a musical staff once you end up with enough numbers. All right, so they're all going to be negative until they get to the place where they change and then turn positive. Yeah, I'm not sure what happened there. But...
See, this is what confuses me. I feel like I'm looking at the trap.
It is a lot. That's why I call them the little balloon strings. I circle the number and then like split it up like that so I can organize myself a little bit better. Because that one is a lot. It's not hard. It just got a little bit overwhelming because there were 4 number lines. And since nothing weird happened, it will alternate. So usually when you figure out what the first section is, you can then just make it alternate. So what is the first section? You have a negative times a negative times a negative times a negative. That'd be positive. And then you can double check it, but it is going to alternate. If nothing weird happened, it's going to alternate. Again, let me get everybody together. They're still writing it down. Just hold on. I got to keep the whole group a group. And believe it or not, that all usually goes really great. It's writing the answer where everybody falls apart. It comes back to this symbol. Greater than 0 means you want which sections? All right, we want the positive sections. And do we want brackets or parentheses? Parentheses, because there's not an equal to. So it's negative infinity until -1. That's this section. Some people also like to shade them in. If you don't like that, forget it. But some people like to color in where their answer is. You do you. All right. Union, what's the next one? Yeah. +1 to 2. And then 3 to infinity. Perfect.
And will we only ever have 4? Like,
I will not give you more than 4 number lines. Again, in theory, you could have many as there are.
we only give us up to 4.
And again, to be clear, so you guys understand what we actually did, if I made you graph this, it's where it's above and below the x-axis. So it would be above the x-axis and then below and then above and then below and then above. That's like what we found. That's like, if you're like, what did we actually do there? If I made you graph it, that's what's happening. That land with anybody?
That
So I do
makes
this like,
sense.
okay.
That makes sense.
Okay. Oh yeah. If I made you graph it visually, it would be in AP calculus. I call it above sea level and below sea level because we do a lot of positive, negative stuff. Yeah, it would be above, below, above, below, above.
And it would be just like the top part.
Well, but it's a rational graph, so there would be asymptotes and stuff. But yes, in theory, it would look like that. All right, this one. You need to slide this over so that you have 0 on one side. So it's going to be 2 over x plus 3, just that first fraction. Like, hey, Miss Cole, it looks like you just recopied it. Sure did. We're going to subtract this to the other side. You have to have 0 on one side before you can do anything else. And if you get lost on this problem, if you at least do that, I'll give you a point. Because this is probably arguably the hardest one on the whole piece of paper. Now, when you have 2 different fractions, you need a common denominator. They're just going to get multiplied by each other is what's happening there. This one's going to get multiplied by the x minus 1, and this one's going to get multiplied by the x plus 3. And it's really just a whole big bunch of algebra. Yeah, that's what you're doing. You're subtracting it to the other side. So when you distribute through here, that's going to give you 2x minus 2, right? Kind of small because we're going to, I made it fit when I worked it out earlier, right? And then here you're distributing not a 4, but a -4. So it's going to be minus 4x minus 12. Again, believe it or not, that usually all goes okay. If you stop there, I can only give you half credit for the problem. It's worth 4. And if you make it there, I usually give you 2. You've lost half the problem. You need for it to still be over the x plus 3 and the x minus 1. If you lose those factors, you have lost half the problem. So I really can't give you any more partial credit because you lost half the problem. So please try to remember to put those in there. So number lines, you're going to have your x plus 3. You're going to have your x minus 1. And then you're going to have whatever that numerator is. I would put the like terms together. So if you put your like terms together, you're going to get what? Huh, that's weird. There's a negative. Huh, that's weird. All right, so yeah, -2x, and then your other like terms will be -14. We just put the like terms together. So 2x minus 4x was -2x. And then -2 and -12 is -14.
So with the x plus 3 and the x minus 1, like I know you have to keep them, but like what's something I can do to like remember to keep them? Because I'm gonna want to cross them out.
You know how on the test, I write how many points everything is worth? When you see on there that it's worth 4 points, you should go, oh, there should be more to this here.
Okay.
Because it's worth more points. I'm very transparent with you. I tell you how much everything is worth. If something's worth a whole mess of points, you should probably do more things with it.
Okay.
Does that help? Go. This one would be -3. This one would be +1. This one would be what?
Positive 7.
-7, good. -2 times -7 would be a +14. -14 is 0. That's why I was asking you guys, because that was the tricky one. Now, if you did +7 instead, I would take off half a point. That's a negative sign issue. That's fine. Now, the first two are going to be negative and then turn positive. They are, you know, quote unquote normal. Nothing weird happened with them. Yeah, now this is where it's backwards. So you can either go, oh, it's just going to be the opposite of that. So it'll be positive and then turn negative. Or you can pick a test number. Can you give me a number smaller than -7? -10. If you plug -10 in here, you're going to get 20 minus 14, which is positive. So like if you are ever not sure, you can pick a test number. All right, so go ahead and put in your balloon strings. And I'm sorry, we're kind of out of room for this one. I apologize.
Is it okay if I just make it straight line?
Yeah,
That's
whatever. Whatever suits you. Whatever floats your boat. All right. What is your overall sign for the first part? Positive, negative, positive, negative, like a battery. Now your answer comes down to this symbol. Do you see how it says less than or equal to 0? So that is the negative sections. And listen, you would want brackets, but out of these 3 choices, the only number you can bracket is which one?
-7.
You can bracket -7. Why can you not bracket the -3 and the 1? They're the troublemakers, okay? So the only number you can bracket is the -7. So it is going to be bracket -7. I'm so mad at myself. I wrote too big. Bracket -7 to what number? I think it's a -3. Yep, -3 parenthesis union, and then what's the other one? Yeah, 1 to infinity. So the only number you can bracket is the -7 because the other 2 are your troublemakers.